Hi, good day to you all. Welcome to another physics class. So today we'll be talking about gravitational field. Gravitational field. What do I mean by this gravitational field? Now, you would have observed that there is what we call a gravitational force that exists between two different bodies. Now, what do I mean by this? Why is it that when you throw an object up, it always comes down? This is as a result of the gravitational pull or the force on the Earth's surface. So usually, gravitational force exists between two different bodies. If you are experiencing a gravitational pull, that means the mass of the body and the mass where the gravitational force is felt are involved. What am I saying? You throw an object up, that means it is coming down. So the gravitational force is at the surface, pulling down the object thrown up. So the object up as well as here are going to experience a kind of force of attraction. It is this force of attraction that is pulling the object down. So that region where gravitational force is felt is called a gravitational field. So the gravitational field the experiment was actually carried out by Newton, and he made us realize that these forces are forces of attraction, because if there is no force of attraction, there can't be a pull. Like poles do what? Like poles repel. Is the unlike poles that attract. So this one here and this one here have a force of attraction. So this force experienced by this object is pulling down this one that is on top. So that region is gravitational field, and Newton has made us realize that the force of attraction can also be explained with this formula. The force of attraction between masses is inversely proportional to the distance between them. To the what? To the distance r between the two objects. And it is also directly proportional to the what? To the product of the masses. The mass of the object coming down as well as the mass of the heart. Do you get the illustration? So now for us to combine these two equations together, we'll be having force of attraction is directly proportional to the product of the masses and inversely proportional to the distance between the two masses. And that was how we arrived at F, directly proportional to M1, M2 over R squared. The square of the distance between the two masses. Now, this G here, you're wondering, why did this G come into play? This is because we have changed our proportionality sign to an equal sign. So we have to introduce a proportionality constant. And the constant here is referred to the gravitational constant. It's a constant given by 6.7 times 10 raised to power minus 11. F here is our force of attraction. M1 and M2 are the masses. R is the distance between these masses. And G is the gravitational constant. So let's solve more questions for proper understanding. Now, let's look at the first question here. The mass of the planet, this is one object, the planet Earth, is about 6 times 10 raised to power 24 kg. And that of the moon, this is another object, is about 7 times 10 raised to power 22. The distance between these two objects, that is the Earth and the moon, is 4 times 10 raised to power 8. Let me adjust the lens. Okay? 4 times 10 raised to power 8 meters. Now we are told to calculate the force of attraction between the Earth and the moon. The force of attraction. First and foremost, what is the formula? Let us write out the parameters for the first example. What are the given parameters? We were given the mass of the earth as 6 times 10 raised to the power 24. The mass of the moon, 7 times 10 raised to the power 22. Now the distance between them, which is r, is 4 times 10 raised to the power 8. Find F. Did you get that? So, from our formula, F equals to what? The gravitational constant. Let me write it here. 6.67 times 10 raised to the power minus 11. So we have M1, which is the mass of the earth, M2, which is the mass of the moon, over the distance between them. Did you get that illustration? Let me rub this place off. Now, so I haven't written out our parameters. Let's go down to the what? To the formula. Now, what is our G? F equals 6.67 times 10 raised to the power minus 11. The mass of the earth, 6 times 10 raised to the power 24. The mass of the moon, 7 times 10 raised to the power 22. Everything over. Remember that it is r squared, so we have to square our r, which is 4 times 10 raised to the power 8 times 4 times 10 raised to the power 8. Did you get that illustration? So now, I'm going to be applying the law of indices. Yeah, remember that the powers are very, very high. So to avoid any error in multiplying, let's apply the law of indices. Now, what do I mean by this? Now, let's speak it out like this. 6.67 times 6 times 7 over 4 times 4. Now, remember that law of indices, if you are multiplying the base, you have the power. So here we have 10 raised to the power 16. Minus 11, 24 will give us 13. 13 plus this will give us times 10 raised to the power 35. Did you get that? Okay, so now let's multiply these two together. 6.67 times 6 times 7. That will give us 280. So we have 280.14 times 10 raised to the power 35. Did you get that? Over 4 times 4, 16 times 10 raised to the power 16. Now this one divided by 16 will give us 17.5 times 10 raised to the power. Now if you are dividing, what will happen to the power? You subtract. That will be 35 minus 16. 17.5 times 10 raised to the power what? 19. Now, if you want to change this one to an appropriate standard form, it's going to be 1.75 times 10 raised to the power 20. Because it is force, that will be Newton. Newton. Understandable? Here we have our G. We have our mass of the earth. We have our mass of the moon over the distance between them. 4 times 4 is 16. You add up the power, 16. This times this times this gave us 280.14. Now what about the powers? Minus 11 plus 24, that will give us 13. 13 plus this will give us 35. Because we are dividing, subtract the power. 35 minus 16 will give us 19. Change this one to an appropriate standard form. 1.75 times 10 raised to the power 20. Is that understood? Now, let's see if we can solve the second example. Let me rub this place off for the parameters. Okay. Now, two bodies are attracted with a force of 754. That is the F is 754 Newton. Now, if the distance is 17.3, that's R is 17.3, then we're given the mass of just one body. Let's say M1 equals 2050 kg. So we are told to find M2. Remember our constant G equals 6.67 times 10 raised to the power minus 11. So let's write out the formula. F equals to gm1 m2 over r squared. Now to make your work easier, let's try and make m2 the subject of the formula. Let's make m2 the subject of the formula, and from there we can calculate it. So we'll cross multiply. Let's cross multiply. So we have fr squared. Fr squared equals to gm1 m2. So to get our m2, it's going to be what? Fr squared over gm1. Simple. What is our f? 754. What is our r squared? That means you are going to square this one. 70.3, 70.3 over our g is a constant, 6.67 times 10 raised to the power minus 11. Then the first mass, 2050. So let's start. 754 times 70.3 times 70.3. That will give us altogether 3,726,335. Or let's approximate just 336 once and for all. Now let's leave this one. Multiply 2050 by 6.67. So this one will also give us 13,673.5. Remember this one has what here? Times 10 raised to the power minus 11. I hope you've not forgotten that. Now let's look at this one. If you want to do this, we can have 37. You can do that all together. 336 divided by 13,673. And that will give us 272.5. Remember that we have this one here times 10 raised to the power minus 11. But this 11 here, when it goes up, it becomes what? Times 10 raised to the power 11. Now, the minus is going to be automatically removed. So here we have 2.725 times 10 raised to the power 11, 12, 13. 13 kg. Wow, quite big. That is the mass of the second object. Is that taken? That is the mass of the second object. All right, we'll continue next class. Bye.